Hi, everyone. I've received a bunch of questions on asking for clarity on the potential energy diagram. So whenever I receive enough questions, probably tells me that I need to expand on a question here. So here we go. Let's use this as a bit of review for some other concepts in thermal chemistry as well. Here I have a reaction. Carbon monoxide reacting with hydrogen to produce methanol, CH3OH. So a few questions about this as well. Here I have the heat term written on the product side. And so what does that mean? So that means that heat is being released. Okay, so the heat term can be written as a delta H. So in this case, the delta H would be negative 128.6 kilojoules. But you can also write the heat term within the equation, and then you just kind of think of it as a reactant or a product. If the heat term's on the reactant side, then heat energy is being put in. If heat's on the product side, it's being released. When you write it as part of the equation, it's always written positive, okay? So then when you pull it out and write it as a delta H enthalpy value, you have to put the appropriate sign here. So heat being released and negative delta H. So a potential energy diagram has two axes. On the vertical axis, you're looking at the change in potential energy. And on the horizontal axis, sometimes you'll see it written as reaction coordinate or reaction progress. The point is, it's not time, okay? This is not a two-scale measure of how quickly. You're just moving from the start of the reaction to the end of the reaction, reactants to products, okay? The whole idea with potential energy diagrams is to look at the relative changes. So remember, the absolute values of enthalpy don't matter at all, okay? And they can't be measured. What we're only interested in here is looking at the change from reactants to products. So here we go. I'll write my reactants over on the left with their correct molar quantities. And that's important because this energy value here, 128.6, is referenced for the production of 1 mole of methanol. So if we had different coefficients here, we would obviously have more or less heat produced. So here's my reactants. The products are going to be further to the right as the reaction progresses. And my product here is CH3OH. And then what we'll do, and I'll draw it in a different color here. We draw a vertical line. Okay. Sometimes you'll see it with 2 arrows. Sometimes you'll see it just going from reactants to products. And here I will write my delta H term. And there we go. So there is a potential energy diagram for this reaction. Reactants listed, products listed. Exothermic reaction, we go from a system of high potential energy to a system of low potential energy, and that potential energy is converted into kinetic energy, which we experience as heat is released from the system to the surroundings. So I hope that's helpful for the assignment and giving some clarity with potential energy diagrams.